Hey, my name is Bruno Mututu, and this is my video for my ALP2. The SLO used here is SLO-17, which says we should use trigonometric identities to rewrite expressions within trigonometric equations and solve, determining all possible solutions and/or solutions on a given interval. So the objective here is to use the addition, subtraction, double angle, half angle, and sum to product identities to rewrite expressions to solve trig equations. A tip to solve this equation is to use the trig identities to simplify the equations and then solve the equations algebraically. Find the solution of the trig equation sine x plus 3 pi on 4 plus sine x minus 3 pi on 4 equals 1 on the interval 0 to pi. Now we know our sine addition function is sine a plus or minus b equals to sine a cos b plus or minus cos a sine b. So here we're going to have, for the first one, we'll have sine x cos 3 pi on 4 plus cos x sine 3 pi on 4 plus cosine x, let me wipe that, plus sine x cos 3 pi on 4 minus cos x sine 3 pi on 4 equals to 1. Now we know since this is negative and this is positive and they're like terms, they're going to cancel out if we don't want to make, and we're going to have 2 into sine x cos 3 pi on 4. Because these are like terms, it's equals to 1. So now cos 3 pi on 4 is negative root 2 on 2, so we have 2 into negative root 2 on 2 sine x equals 1. So now if we want to simplify this, we're going to have negative root 2 on 2 sine x is equals to half. We multiply both sides by 2, we're going to have negative root 2 sine x equals to 1. And then we're going to have sine x equals to 1 over negative root 2. So x is equals to 5 pi on 4 or 7 pi on 4, because we rationalize negative root 2 is going to give us negative root 2 on 2. So I will find the inverse. Solve the equation and determine the solution of cos 3 pi on 2 plus x equals to tangent of pi on 4. So from our cosine function, we know cos a plus or minus b is equals to cos a cos b plus minus sine a sine b. So we will have cos 3 pi on 2 cos x minus sine 3 pi on 2 sine x equals to 1. So cos 3 pi on 2 cosine is 0, so this automatically cancels. So we have negative sine 3 pi on 2 is negative 1, sine x is equals to 1, which gives us sine x equals to 1, and x is going to be equal to pi on 2. And since they didn't precise the interval or the range, it's going to be pi on 2 plus 2 pi n. So solve the trig equation cos 2x plus cos x equals to 0 on the interval 0 to pi. So we could transform this into a quadratic equation. So cos 2x, the best identity here is going to be 2 cos squared x minus 1, and now plus cos x equals 0. We could rearrange this to cos squared x plus cos x minus 1 equals to 0. Now we could factor this and have 2 cos x minus 1 and have cos x plus 1. Yes, equals to 0. Sorry. So from the first one, we'll have cos x equals to half, or cos x equals to -1. So from this one, we could have x equals pi on 3, or 5 pi on 3. And from this one, we could have x equals pi. So these are our answers. Solve 2 cos theta on 5 equals to root 2 on the interval 0 to pi. So when we have this, we'll divide both sides by 2 to isolate cosine function. So divide both sides by 2. So cos theta on 5, cos theta on 5 is equals to root 2 on 2. Theta on 5 is equals to cosine inverse of root 2 on 2, which in radians it gives us pi on 4 and or 7 pi on 4. And now to find theta, we'll multiply both sides by 5. So theta will be equal to 5 pi on 4, or 35 pi